Good day class, welcome to our subject, Thermodynamics 1. I hope that you have already read the SPLM, I gave it to you in our Moodle class. This video will show how to solve our exercises. Exercise number 1. What is the weight of a 66 kilograms mass, man at standard condition? In our solution, it is much better to write the given. This is very helpful when solving complex problems, in order to analyze the problem easily. So, we have the mass of 66 kilograms mass, and acceleration, which is equal to the standard gravitational acceleration of the Earth, 9.8066 meter per second squared. To solve the problem, we will use the formula that force gravity is equal to the quotient of the product of mass and acceleration, and proportionality constant. Substitute the value of mass, acceleration, and proportionality constant. The value of proportionality constant can be get in our SPLM. Cancel the units that can be cancelled, then we have the value of force gravity, which is equal to 66 kilograms force. Exercise number 2. The weight of an object is 50 pounds. What is its mass at standard condition? Writing the given. From the formula of force gravity, we can solve the mass. That mass is equal to the quotient of the product of force gravity and proportionality constant, and acceleration. Substitute the given value and solve for mass, thus we have 50-pound mass. Exercise number 3. Two masses, one is 10 kilograms and the other unknown, are placed on a scale in a region where g equals 9.67 meter per second squared. The combined weight of these two masses is 174.06 Newton. Find the unknown mass in kilograms and pound. Writing the given data. Solving first the total mass, thus we have 18 kilograms mass. Total mass is equal also to the sum of mass 1 and mass 2. Thus, we can solve mass 2. So mass 2 is equal to the difference of the total mass and mass 1, which is equal to 8 kilograms mass. Converting it to pounds, so we have 17.64 pound mass. Exercise number 4. A car whose mass is 2 metric tons is accelerated uniformly from standstill to 100 kph in 5 sec. Find the mass in pounds, the acceleration, driving force in newtons, and distance traveled. Writing the data given. For the mass, we can solve this directly by converting from metric tons to pound mass. So we have 44 10-pound mass. We have other given data. To solve driving force, we need to solve first the acceleration, using the formula that acceleration is equal to quotient of the difference of final and initial velocity and time. Substituting the known value and converting it to meter per second squared, thus we have 5.56 of acceleration. By using force-gravity formula, we can solve the driving force, thus we have 11,120 Newton. Exercise number 5. What is the specific weight of water at standard condition? The standard density of water is 1,000 kilograms per meter cubed. To solve specific weight, we will use the formula that specific weight is equal to the quotient of the product of density and gravitational acceleration, and proportionality constant. Substitute the values, so we have 1,000 kilogram force per meter cube of specific weight. Exercise number 6. Two liquids of different densities, density 1 equals 1500 kilogram mass per meter cube, density 2 equals 500 kilogram mass per meter cube, are poured together into a 100-liter tank, filling it. If the resulting density of the mixture is 800 kilogram mass per meter cube, find the respective quantities of liquids used. Also find the weight of the mixture, local g equals 9.675 meter per second squared. Writing all the given. From the formula density is equal to the quotient of mass and volume, we can get mass is equal to the product of density and volume. Using this formula, we can solve mass 3 is equal to 80 kilogram mass. From the statement of the problem, we can get this relation, that mass 3 is equal to the sum of mass 1 and 2. Substitute the masses with density and volume, we can make an equation, 1500 volume 1 plus 500 volume 2 is equal to 80, we will denote this as equation 1. For the volumes, we can get also this relation from the problem, that volume 3 is equal to the sum of volume 1 and 2, and we will denote this as equation 2. Using equation 1 and 2, we can solve volume 1 and 2, thus, volume 1 is equal to 0.03 meter cube, and volume 2 is equal to 0.07 meter cube. Using the formula, that mass is equal to the product of density and volume, we can solve mass 1 and 2. So mass 1 is equal to 45 kilogram and mass 2 of 35 kilogram. To solve force gravity, we will use this formula, substitute the value, so we have 78.926 kilogram force, or 774 Newton. Exercise number 7. A pressure gauge reading 50 psig in a region where the barometer is 14.25 psia. Find the absolute pressure in psi and Pascal. Writing the given. Using the formula that absolute pressure is equal to the sum atmospheric and gauge pressure. Substitute the given values, so we have 64.25 pound per inch squared, or psia. Exercise number 8. A 30 meters vertical column of liquid, density 1878 kilograms per meter cube, is located where G equals 9.65 meter per second squared. Find the pressure at the base of the column. Writing the given values. Using the formula, that pressure is equal to the product of specific weight and the height of the liquid. Substituting the specific weight by this formula. Thus the formula for the pressure will become like this. Substitute the given data, so you will have 543,681 Newton per meter squared, or Pascal, of pressure at the bottom of the column. Exercise number 9. The vessel contains gas. The manometer contains liquid whose density is 300 pound per feet cubed with Hg equals 50 inch. Find the gas pressure in psi and Pascal. Local G equals 32.11 feet per second squared and barometric pressure equals 14.55 psia. Writing the given data. To solve the pressure of the gas, we used this formula. Substitute the given value. So, we have 8.66 pound force per inch squared. To find the absolute pressure, we will use the formula that absolute pressure is equal to the sum of atmospheric and pressure gauge. So, substituting the given data, thus, we have 23.21 pound force per inch squared, or 160,026 Pascal. Exercise number 10. Derive the relation between degree Fahrenheit to degree Celsius. We can derive this by using interpolation. Interpolation is the determination or estimation of the value of f of x, or a function of x, from certain known values of the function. To know the steps of using interpolation, just follow the video. Simplifying the equation and putting the degree Celsius or degree Fahrenheit in the right side. You can derive the formulas. Exercise number 11. Two gaseous streams enter a combining tube and leave as a single mixture. These data apply at the entrance section. For one gas, area 1 equals 75 inch squared, velocity 1 equals 500 feet per second, specific volume 1 equals 10 feet cubed per pound. For other gas, area 2 equals 50 inch squared, mass flow rate equals 16.67 pound per second, density 2 equals 0.12 pound per feet cubed, at exit, velocity 3 equals 350 feet per second, specific volume 3 equals 7 feet cubed per pound. Find letter A, speed at section 2, and B, the flow and area at the exit section. To solve this problem, it's much better to make an illustration of the problem and the given data in order to analyze it well. For letter A, to solve the velocity, we used the formula that velocity is equal to the quotient of mass flow rate and the product of area and velocity. Substituting the values, so we have 400 feet per second of velocity at point 2. For letter B, finding the mass at point 3, we can solve this by adding the mass of 1 and 2, but we need to solve first the mass at point 1. Solving mass at point 1, we will use this formula. Substituting the values, then we have mass of 1 of 26.04 pound per second. Adding mass 1 and 2, so we can solve mass 3, that is 42.71 pound per second. To solve area 3, we will use this formula, substituting the values, so we have 0.8542 feet squared of area at point 3. Exercise number 12. A 10 feet diameter by 15 feet height vertical tank is receiving water with density of 62.1 pound per feet cube at the rate of 300 gallon per minute and is discharging through a 6 inches diameter with a constant speed of 5 feet per second. At a given instant, the tank is half full. Find the water level and the mass change in tank 15 minutes later. To solve this, first we will make an illustration to analyze well the problem. As we can see, we must identify the water in the tank whether increasing or decreasing. To find this, by subtracting the mass entering and leaving. Solving mass entering, using this formula, and substituting the given data. So, we have 2,490.64 pound per min. Solving mass leaving, using this formula, and substituting the given data. We have 3658 pound per min. Subtracting mass leaving to the mass entering, the result is negative, which means water level of the tank is decreasing after 15 mins. Using the mass of change and density we can get the volume of change, which is 282 feet cubed. So, the decrease in height of tank is 3.59 feet. Then, the water level of the tank after 15 mins is 3.91 feet.